Okay, so this is our lesson on LEDs. First of all, you need to know what a valence electron is. And a valence electron is an outer shell electron. And if we look at the electron configuration for group 1, they all end in S1. So it has one valence electron in its outer shell. Group 2, S2 has two valence. Skip groups 3 through 12. Those are the transition metals. They have a different number of valence electrons in their outer shells. They can vary. Group 13 has S2P1, so therefore that's 3. So I'm adding up the sum of the S and the P orbitals to get me my total number of valence. Okay, group 16 has 6, 17 has 7, 18 has 8, so on and so forth. So you might start to notice the pattern here. We're looking at group 1 is 1, 2 has 2, 3, 4, 5, 6, 7, and 8. All atoms want to form an octet, so they want to have an outer shell of electrons. So they all want to end in S2P6 for a grand total of 8. Okay, so if you look at the periodic table, it's pretty simple how to determine valence electrons. 1, 2, skip a few, 3, 4, 5, 6, 7, and 8. So whatever group you're in, the number of valence electrons is just the last number of that group. So 18 has 8, 17, 7, 16, 6, so on and so forth. Okay, so just a little check. How many valence electrons do each of these have? Well, carbon is from group 14, so it has 4. Nitrogen is from group 15, it has 5. Oxygen has 6 because it's from group 16. Chlorine has 7 because it's from group 17. Sodium has 1 because it's from group 1. So just a little quick check on that. Okay, so what is an LED? It stands for a Lewis electron diagram, so LED, and the arrangement of valence electrons around the chemical symbol. So I'm going to show you how to do that. Okay, so currently this is how these various elements look: carbon, nitrogen, oxygen, and fluorine. Carbon has 4, nitrogen 5, oxygen 6, fluorine has 7. Now, they want to follow the octet rule. So carbon over here, it starts with 4 currently on the periodic table, but it wants to have 8. So it needs 4 more in order to follow the octet rule, in order for it to be full or stable. Nitrogen is from group 15, so it currently starts with 5. So what's going to happen here is nitrogen wants to gain, and it's going to share 3 more valence electrons. So typically nitrogen and all the group and all the elements below it are going to form 3 bonds. Carbon and all the elements below it typically are going to form 4 in general. Oxygen has 6. It wants 2 more, so it's going to form 2 more bonds with other compounds. Group 17 elements like fluorine want 1 more. So typically fluorine is going to form one bond. Okay, so LED practice. What do you do? How do you do these? Okay, so this is where you need to pay close attention. We're going to try this tomorrow. First of all, here's our compound, CH3I. So rule number 1 states count up the total number of valence electrons for each atom. Now this is how many they currently have. So carbon is in group 14, therefore it has 4 valence electrons. Okay, it brings 4 valence electrons to the table. Iodine is going to bring 7 valence electrons to the table. Each hydrogen, we have 3 of them, are going to bring 1. So each hydrogen brings 1, and we have 3 of them. And then you add all these up, we have a total of 14 valence electrons. So basically they bring them all the valence electrons to the table, then they'll divvy them up so that each has 8. As we'll see, hydrogen will only want 2. Next, rule number 2. Arrange the atoms to form a skeleton structure for the molecule. Now the rule is if carbon's present, then that's going to be the central atom. Otherwise, the least electronegative goes in the center, except for hydrogen, which is never in the center. It can't be, and you'll see why. It only wants to form with 2 valence electrons. Now, just a little hint here. It's usually the first element listed in the formula that goes in the center. So in this formula, carbon was listed first. And so typically 99% of the time, that's going to be the first element. That's going to be the element that goes in the center. Okay, next rule is we'll go ahead and draw a skeleton structure. So carbon goes in the center. Think about your element as having 4 sides to it. Okay, so it can fit a maximum of 4 atoms on each side. So it doesn't really matter if the iodine goes on the top, sides, or whatever. This is a 3D molecule. We're just doing a 2D drawing of it. Okay, rule number 3, we're going to add unshared pairs. So you want to add electrons in pairs so that each atom is surrounded by 8. So we want each atom to have the octet rule. They currently don't, but we're going to have them bond so that they do. Hydrogen is the exception. It only wants 2 valence electrons. Then we're going to connect the atoms by electron pair bonds. So all elements are going to want 8, except for hydrogen only wants 2. Okay, so we have 14 valence electrons to work with. So what we're going to start doing is we're going to start adding them. Okay, here's 1, 2. Okay, we're going to add them in pairs. So hydrogen has 2. It's good. Then we're going to add 2 more for that hydrogen. Then this hydrogen is going to get 2. All right. Now, the thing is, when you put 2 valence electrons between 2 atoms, that means they're sharing them. Okay, we're making covalent bonds here. They're sharing electrons. These 2 count 2 for the hydrogen, but they also count 2 for the carbon. So really carbon has 2, 4, 6 around it so far. Okay, hydrogen's happy, it only wants 2, but all other elements want 8. Okay, so we've used 6 of our valence electrons so far, and we have a total, remember, of 14. So we've got 8 more. What do we do with them? Well, we're going to put them around the carbon and then the iodine. So 2, 4, 6, 8. Okay. Now, iodine, if we look at iodine, it has 2, 4, 6, 8. It's happy. If we look at carbon, it has 2, 4, 6, 8. Because remember, when they are between 2 atoms, they count for both of the atoms. Okay, so these 2 count 2 for carbon and 2 for iodine. Okay, now these right here are what we call single bonds. Okay, so what we can do once we've drawn them is we can draw it like this. A line is going to represent 2 valence electrons. It's going to represent a single bond. So we do iodine like that. These right here are called lone pairs. Okay, lone pairs because they're alone. They're not bonded to anything. Okay, so those are the bonds. So a 2 electrons that are separated by 2 atoms, that is a single covalent bond. Okay, so next we're going to look at double bonds. Double bonds. When do we need a double bond? Well, let's go ahead and set these up. All right, now carbon comes from group 14, which supplies 4. So we have 4. We have 2 carbons. Okay, there's the 2 right there. Each supply 4 electrons. Plus, we have 4 hydrogens, each supplying 1. So if we add up all those, that means we have a total of, I'm going to write it, 12 valence electrons here. 8 plus 4 gives us a 12. So let's go ahead and start setting it up. 2 carbons. We're going to add our hydrogens. It doesn't really matter where you add those hydrogens. All right, let's start adding valence electrons. Okay, we have 12 of them. Each hydrogen wants 2. So we have 12 to use. So 2, 4, 6, 8. Now, hydrogen's all happy. If you look at carbon, each carbon has 4 around it. So let's go ahead and make a single bond there. So it's going to attach the 2 carbons. So we use 6, 2, 4, 6, 8, 10, 12. 14. Oops. Get rid of that. Okay, so we've used all 12 of them. Here's the problem. This carbon right here only has 6. It's got 2, 4, 6. Okay, this carbon's good because it's got 8. So here's what we're going to do. What we're going to do is we're going to take one of these pairs right here. Instead of it just counting for this carbon, we're going to go ahead and share it right here. So let's see, let's get rid of these two. Oops. Okay. So now what we've got here is each carbon has 8. This one has 8, this one has 8. What we have here is a double bond. Okay? These 4 electrons count 4 for this carbon, and they count 4 for this carbon. So each of the carbons have 8, each of the hydrogens have 2, and so they're all happy. So let's go ahead and rewrite it with our lines. It would look like this. Okay, so double bond. Now, how do you know when you need a double bond? When you're too short. When you're 2 valence electrons short, that's when you know you need to take one pair and share it between 2 atoms instead of it just counting for a single atom. All right, let's do a triple bond. Okay, we have N2. So each nitrogen comes from group 15, so they each supply 5 valence electrons. So we have a total of 10. Let's put our 2 nitrogens right here, and so we're going to start adding them. 2, 4, 6, 8, 10. Uh-oh, we're going to see real quick, this nitrogen right here only has 4. It wants 8. This nitrogen's fine, but here's what we're going to have to do. We're going to have to start sharing some pairs. Okay, so we're going to take this pair right here, and we're going to put it right here. Sorry, my erase function is not working. And then we're going to take this pair, we're going to place it right here. Okay, so now what we've got here is we've got 6 valence electrons. 6 counts for this nitrogen, and this 6 also counts for this nitrogen. Each nitrogen have 2 lone pairs, so they both have 8. All right, how do you know when you need a triple bond? When you are 4 valence electrons short. Okay, so that concludes our lesson on LEDs.